This video provides a summary of the procedures used for testing the compressive strength of hardened Portland cement concrete cylinders, AASHTO T22. This procedure is used in engineering practice in order to ensure that the Portland cement concrete placed on a project meets the strength required by the design. This test is critical since using Portland cement concrete that does not meet the strength requirements can result in costly and dangerous failures. When performing compressive strength testing, the following safety precautions are required: safety glasses, closed-toed shoes, and a hard hat. Additionally, it should be mentioned that at no time should the safety cage around the apparatus be opened while the machine is running. The following equipment, materials, and supplies are required for compressive strength testing: hardened 4-inch by 8-inch Portland cement concrete cylinders, 4-inch diameter end caps, a testing machine capable of applying a controlled rate of loading, a system capable of measuring and recording the ultimate load applied to the specimen. With the machine off, place the 4-inch diameter bottom end cap into the device and carefully center it below the loading head. Next, place the 4-inch diameter concrete cylinder onto the end cap. Place the top end cap onto the concrete cylinder. Verify that the specimen is still aligned with the loading head, and then close the door to the safety cage, securing it with the pin. The TA will ask you to compute the proper loading rate in pounds per second that the machine will have to apply in order to achieve the specified loading rate in terms of PSI per second. AASHTO T22 in your lab manual specifies that the loading rate should be between 20 to 50 PSI per second. Aim for the middle of this range, 35 PSI per second. In order to achieve 35 PSI per second, the machine loading rate can be calculated as follows. Multiply the loading rate in terms of pressure by the specimen cross-sectional area, equal to pi times the radius squared. For this test, the radius is 2 inches. A target rate of 35 psi per second and 2-inch specimen radius yields a loading rate of 440 pounds per second applied to the specimen by the machine. Once calculated, the TA will input the loading rate into the testing software and then begin the test. The computer will record the load applied to the specimen as a function of time. You will see an increase in load up until the point of failure, at which time the load will begin to decrease. Depending on the loading rate and material used, this peak may be sharp or wide. The concrete strength can be calculated by taking the peak load obtained and dividing by the specimen cross-sectional area. The compressive strength test should be repeated on 2 additional 4-inch diameter cylinders. By averaging the results, an estimate of the concrete compressive strength can be obtained, which will be needed for other calculations in the lab.